Module 1, Lesson 13, Rotations. We begin this lesson with a review of some of the major concepts from our previous lesson. A rotation is distance preserving. That means that it's going to map segments onto segments of equal length. They are also angle preserving, which means that our angles are going to map onto angles of equal measure. That means that our segments are congruent and our angles are congruent. The size, shape, and orientation of our figure stay the same when we rotate about a point. And rotations can be done about any point in the plane. A rotation moves x degrees about a point called the center of rotation. Okay, so let's look at our diagram. R is going to be our center of rotation. So we are going to be taking our pre-image triangle UVW, and we are going to be rotating it, moving it in a circle around this point R, around our center point. So if you can imagine drawing a circle around this center point, our triangle is going to move around that circle. And these are just the hands of a clock. Think about the hands of the clock moving around in a circle. So some properties of our rotation. The first is the image of R, so our center of rotation, is going to be itself. This is the center of the clock, and it turns around in a circle, but it does not change position. So R becomes R prime. You label it R prime, but it doesn't move in the plane. Now our text uses some notation that we need to learn to read here. And this big capital R says that we have a rotation, and the subscript R tells us our center of rotation travels x degrees, and in the parentheses is the point or figure that we are moving around the center of rotation, equals our image point. So this is read: the rotation of point R, x degrees about our center of rotation R, is R prime. So that says that it is itself. Now for any other point, such as point V on our triangle here, we could choose V, U, or W. This is true for all of them. For our point V, the length of RV prime, so that's this length right here, from the center point to our image point, is equal to length RV. That's from our center point to our pre-image point. These are congruent, right? If they are equal length, that means that they are congruent. The segments are congruent. That should be no surprise. Those are just the radii of our circle. Our angle measure that this creates, angle VRV prime, the measure of that angle is x degrees. This is our angle of rotation. So our notation here says that for point V, a rotation of point V x degrees about our center point R is V prime. Our image is V prime. Now the fact that these two lengths are congruent is going to be important to us later. Our angle of rotation is positive if we're moving counterclockwise, which is that way, or negative if we are moving clockwise, which goes that way. So it's either a positive or negative number of degrees that we are moving around this circle. Now, why is it positive in the counterclockwise direction? Think of our coordinate plane. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. When we move around the coordinate plane, we move in a counterclockwise direction. So pretty nifty. A rotation about a point is an isometry. Do you remember what isometry means? That means that corresponding parts, so segments and angles, all of our segments and angles, corresponding segment and angles, are congruent. Angle preserving, distance preserving. Some constructions that we are going to need to be able to do. First, we're going to need to be able to construct a rotation. So we want to, let's read our terminology here, let's read our notation. We want to rotate triangle LOB 100 degrees about point C. There's our center point. So the first thing I always do is find my center point, my center of rotation. Now we draw segment CO. So I choose a point on triangle LOB and draw my segment. And then I use a protractor to draw a 100-degree angle. And then there's a 100-degree angle. And then I'm going to use my compass to construct CO prime. So a compass is just a measuring device, and remember this segment is going to be congruent to this segment. So I just use my compass to measure CO, and this is just a circle over here, right? And I just mark O prime. There's my first image point. And then we just continue on, repeat for point L, draw CL, use your protractor to measure a 100-degree angle, use your compass to measure CL prime. There's L prime. We do the same thing for point B. Draw segment CB, use your protractor to measure a 100-degree angle, and use your compass to find point B prime. And then when we have finished, we have O prime, L prime, and B prime, and we have constructed the image of triangle LOB. So that's not too bad. Now our next construction, finding the center of rotation, this is where those congruent radii become important. How are we going to find the center of rotation? Well, let's take a look at these two segments here. Segment CO, we know, is congruent to segment CO prime. O to O prime is just another segment that we can draw in. What do we know about a point that is equidistant from the endpoints of a segment? That's right, that point is on the perpendicular bisector of the segment. So how are we going to find the center of rotation? We are going to connect our image and pre-image points with a segment, and then we are going to construct the perpendicular bisector of that segment. Remember how to do that with your compass? And then we are going to take two more points and connect our image and pre-image points and draw the perpendicular bisector of that segment. Point where our perpendicular bisectors intersect is our center of rotation. So if you think about this point on our perpendicular bisector here is equidistant from those two image points, or image and pre-image points, it's also equidistant from these 2 points, my image and pre-image points. And do you see the radii of our circle here? That's the circle that maps A to A prime. And here's the circle that maps B to B prime. Now, if you repeated this for points C and D, you would end up with the same center of rotation. So these are kind of fun constructions that we are going to be doing.